Are you a jam student in the science department and you can't solve this question? The question says, what is the dimension for kinetic energy, Ke, where the formula for kinetic energy is half mv square, that is half times what? Mass times velocity squared. So now to solve this, you need to note, but first let's bring down our formula where we have kinetic energy is equal to 1/2 mv square, right? Now the first thing you need to do is that you need to know the dimension for mass and you need to know the dimension for velocity. All right, so where the dimension for mass m is equal to what? Capital letter M. All right, and the dimension for velocity v is equal to what? We don't know yet, but I'm going to show you how to derive the dimension for velocity. Okay, so remember the formula for velocity is what? Is displacement over time. Okay, so now what's the unit for displacement? The unit for displacement is what? Is meter. What's the unit for time? The unit for time is what? Is seconds. And remember, for you to get the dimension of any quantity, you need to get it using the what? The unit of that what? Quantity. All right, so now from here, you know, meter over second still means what? Meter per seconds, or you say meter seconds raised by what? -1. So from here now you can actually determine the dimension for meter and seconds. Okay, so now I want to leave you with some few basic dimensions you need to know before you can solve any question under dimension in physics. Okay, so you need to note that for the units of length, which is meter m, the dimension is L. Okay, now for the units seconds S, the dimension is letter T, capital letter T. For the units kilogram, that's represented as what? Kg, that is the symbol is Kg. The dimension is capital letter M. For the units Kelvin, which is represented as what? K, the dimension is theta. For the units ampere, the symbol is A and the dimension is I, capital letter I. For the units mole, the symbol is MOL and the dimension is capital letter N. For the units candela, the symbol is CD and the dimension is capital letter J. And whenever you are solving for dimensions and you come across a number, all right, numbers are represented as what? Okay, they are known as constants. Okay, numbers are known as constants. So for numbers or constants, okay, that's number, any number at all. All right, it can be a fraction, it can be a whole number. The unit is that they are dimensionless, that is, they don't have what? Dimension. They are dimensionless. Okay, now if you have watched this video to this extent, please, I want you to do something for me. I want you to like, share, follow, and more importantly, I want you to repost this video so to get to students who really need it. Let's continue, guys. So from here now we can determine what? The dimension for velocity. Okay, so now where we have m is what? Is meter. So the dimension is going to be what? L. Then for s is what? Dimension for s is what? Is capital letter T. It will be what? T. And remember, s was raised to the power of -1. So the dimension for velocity is LT raised to the power of what? -1. Now we can go straight and get the dimension for what? Kinetic energy, which is what? Half mv². Okay, by substituting the respective dimensions of mass and velocity. So now from our formula where we have Ke is equal to 1/2 mv². All right, so now Ke will be equal to 1/2. Now what's the dimension for mass? Dimension for mass is what? Is capital letter M, right? Now times what's the dimension for velocity? The dimension for velocity is given already, all right, as I said before, which is what? Capital letter LT raised to the power of what? -1. And remember that velocity was raised to the power of 2. Don't ignore it, put it there as well. Okay, so from here now, for us to simplify this part, we need to use a law in indices. That law or that rule states that whenever you have a raised to the power of b into bracket raised to the power of x, it means what? You have to multiply this b and this x together. So you have what? A raised to the power of bx. Okay, so that's what we're going to do here in this case. So now we are going to say our kinetic energy is equal to 1/2 then multiply by what? This power of 2 here is going to multiply the degree or power of L and the degree or power of what? T. Okay, so now what's the power of L? The power of L is 1, so 1 times 2 we have what? We have L raised to the power of what? 2. Alright, now for this part where we have T raised to the power of minus 1, you multiply this 2 by the minus 1, then 2 times minus 1 we get what? We get T raised to the power of what? Minus 2. Alright, so from here now we can multiply through, then we have what? We have kinetic energy is equal to what? 1 over 2 ml square T raised to the power of what? Minus 2. Now remember what I said. I said for numbers or constants, they are what? Dimensionless what? Values. So the final answer to this question is that our kinetic energy will be equal to what? Ignoring the constants, which is what? 1 over 2. Our kinetic energy, the dimension for our kinetic energy will be equal to what now? Equal to meter length square and what? Time raised to the power of what? Minus 2. So this is the correct dimension for kinetic energy in physics. Like, share and follow for more.